Today I'm here in Ponta Grossa, Piranha, to show you how Gua Sistemas makes these smart conveyors. But we also came to Amazon's warehouse here in Cajamar, Sao Paulo, to see how they work in practice. Shall we check it out? In any type of warehouse or factory, there are thousands or millions of things that need to be moved from one place to another all the time. If this is done by people pushing carts or even by robots, it can create traffic that's impossible to organize. And that's why conveyor belts exist. They're like smart roads. Here in Ponta Grossa, they have this conveyor belt, this demonstration circuit, and it's really cool for us to understand how each part works. The structure underneath is similar to a roller coaster with these steel supports. The cool thing is that they're telescopic, so you can make them higher or lower by adjusting these little holes here. All the supports are made right here. They start from huge coils of steel, which are cut, drilled, bent, and painted. It's not only the support made from coil steel, but all Amazon structures. For horizontal support, there's a rail you can't see right now, but I'll remove this cover. Even the electrical part will be all inside. It's also made here, and through the holes, you can see that it's all modular, so you can fit the pieces together. On this side of the circuit, we'll have a canvas treadmill, similar to the one at the gym. But this one has a central motor, which can control up to 20 meters of treadmill. For it to be able to pull the canvas, it will pass down here through a kind of S shape, which has motorized rollers that will pull the treadmill. Over here on the other side, the treadmill is a bit different. It's made up of rollers, and this system is much cooler than you think. First, you can see that all the rollers spin at the same time. So it's not just a dead piece sitting there, just letting the box slide over it. It actually pushes the goods. It gives traction. And where is the central motor that makes everything spin? It's inside the roller. So there are some motorized rollers that are hidden here. On this conveyor, there's one of these about every 90 centimeters. And for all of them to work at the same time, here on the side, we have a set of belts. Each belt connects the roller behind it with the one in front. These colored rollers have a rubber coating, which is to give a bit more traction. And the ones I found the coolest are the rollers that are here on the curve, because they're conical. The diameter here on the inside is much smaller than the one on the outside. This makes it similar to an oval racetrack, where you have a steeply banked turn. This is important because otherwise the box would slip out of the curve when it arrives. The conical shape comes from a cover placed around the cylinder, not the cylinder itself. Here, in this section, we can see that the distance between the rollers and their width can vary a lot. This depends on the type of box that's being transported. Since this is a demonstration, both ways of working are shown. One really cool thing here at the beginning is this equipment. It can direct the box to different conveyors. The name of this is MRE, which comes from the English move route equipment. Here, the equipment is still being assembled, so we can see inside. Each of these little wheels is actually a motorized roller. The motor is inside here, and this horizontal movement will be done by servo motors that are down here. As they turn, the whole assembly turns on top. All of this is possible because for every 2 motorized rollers, we have a controller board. It can be controlled remotely and can stop the motor, speed it up, give it more power, or cut the power the moment I put my hand on it. A big difference between the belt conveyor, which looks like a gym treadmill, and the roller conveyor is that the belt conveyor provides a more continuous and uniform transport. Here we can control each motor individually, so it's possible to have a greater accumulation of boxes. While one part of the conveyor is moving, the other can stop, direct the box to one side or the other. The transport can be much more complex. One thing that surprised me about the conveyor as a whole is that it's safer than I thought. I used to think that if I put my hand between the rollers, my fingers would get caught. But that doesn't happen, because one is spinning inward and the other is spinning outward. So, if I put my hand on top, it's just pushed forward, like the box. In fact, if I put too much force on the rollers, they stop. And if I let go, they start moving again. The whole conveyor belt system is controlled by the brain, which is this machine. We can control what happens on the conveyor belt through this little screen, which is technically called an HMI, or human machine interface. From a distance, it looks like a refrigerator, and when you think about how it works, you might imagine it's similar to your home computer, but it's nothing like either of those things. Let's open it up and take a look. Check this out. Here we have a battery. In this spot, I have the connections with those little boards we just saw. The actual brain, where the software is right here. Then we'll have all the communication control and the electrical control of the conveyors. Amen. Everything you're seeing here is made at GUIA Sistemas, from the design on the computer to the assembly of the panel and the installation at the distribution center. But I told you we were going to see what the roller's motor looks like inside. It's going to be way cooler than that because here, they're made from scratch. The raw material is steel tubes that arrive 6 meters long. They get a layer of zinc, are cut and go through beveling, which means adding a beveled edge for a better finish and easier fitting of the internal parts, which, yes, are also made here. At the end of the rollers, there's a bearing, a support made of plastic. It's made using an injection molding machine. That machine melts the raw material and presses it into the mold. This part will get a bearing and a shaft with a spring. So you can see exactly how the assembly is done. We're going to do it here in a very manual way. Manual. And finally, the motor has arrived, which, as you can see, has the exact shape of the inside of the tube. It's a 24-volt motor that has a reduction gear. In other words, it turns slowly, but it's very strong. The final fitting, so this part never comes out again, is done with a hydraulic press. They left it for me to do here. Let's see if it works in the end. Look, I fit the roller into the press and operate it with my foot. I need to press a little more. And when I thought I had finished my task, I still had to do the other side, and then use a dial indicator to check if the tube wasn't over. At the end, there's a computer test to see if the engine is working properly. Roller approved. Let's see how they're fitted onto the conveyor belt. Finally, we'll see the conveyor belt in action. First, the motorized rollers go in, and then the free rollers are installed, which are connected using the belts we've already seen. One thing that makes the job a lot easier is this retractable axle, which looks like the roller we use to hold toilet paper, because with it, the roller is attached to the rail without needing a nut or anything. The last step will be to prepare all the electrical and electronic parts, LD, which includes the board that controls the motors and a sensor for each motor. It works like this. It sends out a beam of light. It's reflected by a mirror on the other side and comes back, so it can tell if a box is passing through here or not. And this is very important because then you know exactly what's passing at each point of the conveyor belt, and you can control the motors individually, besides saving energy, because then the conveyor only works when the sensor is triggered. In the end, we'll have several modules that can be assembled in different ways in the factory or warehouse, depending on each client's needs. And all of this is tested here on the computer first in a simulation to see if any box will get stuck if the curve has a wide enough radius. They even know the friction each box will have with each roller to calculate the distance between one box and another. The work in Ponta Grossa ends here, but a GUIA Sistemas job doesn't, because they still have to assemble all these conveyors and integrate them into the client's system. Shall we see all this working in real life? In the end, everything that GUIA develops is so that the product you bought gets to your house as quickly as possible. And Amazon is one of the best examples of that. They've been in Brazil for years, and they keep expanding. There are already more than 200 logistics hubs in all Brazilian states, and 150 million products offered on the Amazon Brazil website. They invest heavily in technology throughout the operation to keep speeding up deliveries, which already cover 100% of Brazilian municipalities. This one we're in, for example, is the most technologically advanced distribution center in Latin America, with more than 75,000 square meters and capable of processing 9,000 to 9,500 packages per hour. At the entrance, the products are sorted and sent by conveyor belts to the warehouse. There, each one goes to a shelf or a compartment. When a purchase is made, employees take products from the shelves and put them on conveyor belts. In the packing area, boxes from various orders come together and are placed into packages. Then, each package receives a label with the address and goes to the trucks. Let's develop this entire operational flow. Let's be honest, right? You'd never imagine there's so much cool stuff, so much technology in these conveyor systems used in distribution centers, industries, and huge warehouses. And the coolest part, everything is planned and produced practically from scratch here in Brazil by Guia Agrisystems. We watched the video on how the conveyor works, and I wanted to ride it. That's not recommended, just so you know. Wow, it feels really good. Guys, if this isn't worth a like, I don't know what is. I wish I had one of these at the airport hub.